Hi everyone, welcome to another video, and everyone who is watching from India, happy Dasara, and hope this festival season is going awesome for you. And today we're going to start a new series called patterns, where we're going to discuss about various patterns that we observe in various problem solving or DSA questions. And today's video will be on the fundamentals of prefix sum pattern. Prefix sum is a very important pattern because it definitely reduces the time complexity of various questions, right? Various problems. So let's understand what is prefix sum. Okay, so we're going to discuss about prefix sum. As the name indicates, right, the prefix is in the name itself. It says that as we go ahead in a vector or in an array, we're going to keep calculating the sum of the prefixes from that point up to that point, and we're going to get a new array that kind of stores the prefix sum, or you can say cumulative sum, right? And let's understand that. For example, let's assume that we have an array like 2, like 4, 3, and maybe 5 and 1. Okay, and let's write down their indexes, that is start from 0, 1, 2, 3 and 4, right? Now in this particular array or vector or whatever you want to call it, list, right? If somebody asks us to calculate the value from index 1 to maybe index 3, right? So what we're going to do now, we're going to start iterating from index 0, and the time we reach at index 1, we're going to start creating our sum, that is 1. Then when we go to 2, we're going to add 2. Then we're gonna, here it will be 4, it will be 3, and when we gonna do third index, that's 3, the value will be 5, and we're gonna get the sum, that is 5, 3 and 12, right? That is 12. And then in the same question again, someone asks us what is the sum of uh, the subarray or something like from index 2 to index 4, right? From this section maybe. Then again we need to start iterating from index 0. The time we reach at index 2, we're gonna start calculating our sum, that is 3. Then we're gonna go to third index, that is, then we add 5, and at the end we're gonna add 1, then we're gonna get 9, right? So every time someone asks us the sum from a particular index to a different index, we have to iterate to the array, right? Every time. Or let's, the worst case in scenario will be OFN. So every sum, every sum from one index to another index will be OFN, right? So now let's go for our what is cumulative sum way. So what you're going to do is you're going to create an array, right? Our prefix sum array. When we are at index 0, we will be calculating sum up to that particular index, that is 2. Then when we go to index 1, we're gonna calculate sum up to that particular index, that is 4 plus 2, that is 6. When you go to index 2, then we're gonna add 3, that will be 9. Then when we go to index 3, the sum will become 14. And at the end, when we go to index 4, the sum will become 15. Okay, and this will become a OFN operation at the first time when we go from index 0 to the last index and calculate our sum, right? OFN operation. Now see, now someone asks us the same question to calculate sum from index 1 to index 3. Now we are asked to calculate from index 1 to index 3. So we already have sum from index 0 to index 3. So just we have to subtract the value of index 0. So that will become 14 minus 2, that is 12. We got the same answer. Now let's try the second question. If someone asks us to calculate the sum from index 2 to index 4. Now you already have the cumulative sum up to index 4, that is 15. And now 15 contains the sum from the beginning to end, and we don't need the sum up to one index, right? So we can go to one index, that is 6, and we just can subtract that 15 minus 6, and that is 9. We get the same answer. And every of these operations are now OF1. Now hope you're able to see the advantages here, right? We don't have to iterate through the same array to calculate any sum. Once we calculate the prefix sum, that is OFN operation, then we just get any sum from any subarray sum in one OF1 operations. So there is a huge leap in the time complexity, or performance, I can say. So now then, let's try that with coding. Okay, so we're gonna just the basic coding to calculate a prefix sum. So let's assume that we have an array. Let's do the same thing like 2 4 2 4 3 5 and 1, right? This is our example array. Okay, now let's write a function called prefix sum. Prefix sum. And we're going to pass an array called nums. And now let's write a for loop. Let's index I. Now array will be nums. And every element is fine. So if I equals to 0 equals to 0, or we can start from just 1, right? Because our 0th index will remain the same. So let's start from 1, and every time we're gonna go ahead, then we can just replace the nums of I equals to num of I plus nums of I minus 1. Perfect. And at the end, we just have to return the nums. Simple. So let's try this now. Let's console dot log, and let's give our array, this particular array, to the prefix sum, and now see what it's returning. Node dot intro. So we got the desired answer. It is a cumulative sum. So this is how we're going to calculate our prefix sum array, and we in different based on the what the the problem asks. Based on that, we're going to use these calculated numbers. So that's that. Thank you for watching, and see you in another video. Thank you very much.